The study was conducted by researchers from the Department of Computer Science, Lau School of Engineering at Southern Methodist University, which one is the best and their commercial terms of service to protect customers from copyright infringement claims. Researchers tested the idea that an AI model may have an advantage in self-detecting its own content because the detection was leveraging the same training datasets. What they didn't expect to find was that out of the 3 AI models they tested, the content generated by one of them was so undetectable that even the AI that generated it couldn't detect it. AI content detection. Many AI detectors are trained to look for the telltale signals of AI-generated content. These signals are called artifacts, which are generated because of the underlying transformer technology. But other artifacts are unique to each foundation model, the large language model the AI is based on. These artifacts are unique to each AI and they arise from the distinctive training data and fine-tuning that is always different from one AI model to the next. The researchers discovered evidence that it's this uniqueness that enables an AI to have a greater success in self-identifying its own content, significantly better than trying to identify content generated by a different AI. Bard has a better chance of identifying Bard-generated content and ChatGPT has a higher success rate identifying ChatGPT-generated content, but the researchers discovered that this wasn't true for content that was generated by Claude. Claude had difficulty detecting content that it generated. The researchers shared an idea of why Claude was unable to detect its own content, and this article discusses that further on. Methodology. The researchers tested 3 AI models: ChatGPT 3.5 by OpenAI, Bard by Google, Claude by Anthropic. All models used were the September 2023 versions. A dataset of 50 different topics was created. Each AI model was given the exact same prompts to create essays of about 250 words for each of the 50 topics, which generated 50 essays for each of the 3 AI models. Each AI model was then identically prompted to paraphrase their own content and generate an additional essay that was a rewrite of each original essay. They also collected 50 human-generated essays on each of the 50 topics. All of the human-generated essays were selected from the BBC. The researchers then used zero-shot prompting to self-detect the AI-generated content. Zero-shot prompting is a type of prompting that relies on the ability of AI models to complete tasks for which they haven't specifically trained to do. Test 1. Self-detection of own text content. Result. It must be noted that the researchers acknowledged that their sample rate was low and said that they weren't making claims that the results are definitive. Below is a graph showing the success rates of AI self-detection of the first batch of essays. The red values represent the AI self-detection and the blue represents how well the AI detection tool 𝐓𝐞𝐿 performed. Bard did fairly well at detecting its own content and ChatGPT also performed similarly well at detecting its own content. 𝐓𝐞𝐿, the AI detection tool, detected the Bard content very well and performed slightly less better in detecting ChatGPT content. 𝐓𝐞𝐿 essentially failed to detect the Claude-generated content, performing worse than the 50% threshold. Claude was the outlier of the group because it was unable to self-detect its own content, performing significantly worse than Bard and ChatGPT. The researchers hypothesized that it may be that Claude's output contains less detectable artifacts, explaining why both Claude and 𝐓𝐞𝐿 were unable to detect the Claude essays as AI-generated. So, although Claude was unable to reliably self-detect its own content, that turned out to be a sign that the output from Claude was of a higher quality in terms of outputting less AI artifacts. 𝐓𝐞𝐿 performed better at detecting Bard-generated content than it did in detecting ChatGPT and Claude content. The researchers hypothesized that it could be that Bard generates more detectable artifacts, making Bard easier to detect. So in terms of self-detecting content, Bard may be generating more detectable artifacts and Claude is generating less artifacts. Test 2. Self-detecting paraphrased content. Result. The researchers hypothesized that AI models would be able to self-detect their own paraphrased text because the artifacts that are created by the model, as detected in the original essays, should also be present in the rewritten text. Here is the graph that shows the results of this specific test. However, the researchers acknowledged that the prompts for writing the text and paraphrasing are different because each rewrite is different than the original text, which could consequently lead to a different self-detection results for the self-detection of paraphrased text. The results of the self-detection of paraphrased text was indeed different from the self-detection of the original essay test. Bard was able to self-detect the paraphrased content at a similar rate. ChatGPT was not able to self-detect the paraphrased content at a rate much higher than the 50% rate, which is equal to guessing. 𝐓𝐞𝐴T performance was similar to the results in the previous test, performing slightly worse. Perhaps the most interesting result was turned in by Anthropic's Claude. Claude was able to self-detect the paraphrased content, but it was not able to detect the original essay in the previous test. It's an interesting result that Claude's original essays apparently had so few artifacts to signal that it was AI-generated that even Claude was unable to detect it. These tests yielded almost unpredictable results, particularly with regard to Anthropic's Claude, and this trend continued with the test of how well the AI models detected each other's content, which had an interesting wrinkle. Test 3, AI models detecting each other's content, result. The next test showed how well each AI model was at detecting the content generated by the other AI models. If it's true that Bard generates more artifacts than the other models, will the other models be able to easily detect Bard-generated content? The results show that yes, Bard-generated content is the easiest to detect by the other AI models. Here is the graph that shows the results of this specific test. Regarding detecting ChatGPT-generated content, both Claude and Bard were unable to detect it as AI-generated, just as Claude was unable to detect it. ChatGPT was able to detect Claude-generated content at a higher rate than both Bard and Claude, but that higher rate was not much better than guessing. The finding here is that all of them weren't so good at detecting each other's content, which the researchers opined may show that self-detection was a promising area of study. At this point, it should be noted that the researchers don't claim that these results are conclusive about AI detection in general. The focus of the research was testing to see if AI models could succeed at self-detecting their own generated content. The answer is mostly yes, they do a better job at self-detecting, but the results are similar to what was found with 𝐓𝐞𝐴T. Conclusions and takeaways. The results of the test confirm that detecting AI-generated content is not an easy task. Bard is able to detect its own content and paraphrased content. ChatGPT can detect its own content but works less well on its paraphrased content. Claude is the standout because it's not able to reliably self-detect its own content, but it was able to detect the paraphrased content, which was kind of weird and unexpected. Detecting Claude's original essays and the paraphrased essays was a challenge for 𝐓𝐞𝐴T and for the other AI models. But of course, the weird part is that Claude was also unable to self-detect its own original content, unlike the other two models which had a higher success rate. The researchers indicated that self-detection remains an interesting area for continued research and proposed that further studies can focus on larger datasets with a greater diversity of AI-generated text, test additional AI models, a comparison with more AI detectors, and lastly they suggested studying how prompt engineering may influence detection levels. Read the original research paper and the abstract, and a PDF link will be shared in this video description below.